Hi class. In this lecture here, we want to continue talking about the relationship between two variables by talking about a very important concept called regression. And so you'll hear me say things like best fit line, regression, least squares regression line. It's all going to mean the same thing. And so what I want to do in this lecture here is I want to introduce the topic of, what exactly is regression, why we need it. And then we're going to rely very, very heavily on our calculator as we have been. So we're going to continue using the same example from the previous couple lectures where we're talking about hours of study and the exam grade. So in the previous lecture, we looked at correlation, and we saw that these two variables were highly correlated, okay? And because the R value was close to +1, it means there's a strong positive linear relationship between the two variables. Okay, so we've talked about the relationship now. And so in regression, what we want to do, what's next? And so since we know that there is a linear relationship between the variables, okay, so again, here are our variables. We have X is the hours of study, and Y up here, okay, this is the exam score. Okay, we want to describe or model the relationship with a mathematical equation. Okay, so we want to describe this. Okay, we want to fit this data with a mathematical equation. Okay, so describe the relationship with a mathematical equation. And look, if we know that there is a linear relationship, okay, since there's a linear relationship, okay, all we're going to do is we're going to use the equation of a line. Because like, watch what happens here. I'm going to put over here this straight line, this equation of this line here, okay, or this visual of the equation of the line. And look, that line does a really, really good job modeling the relationship. Okay, so what we're going to use, if you remember from some of your previous math classes, the equation of a line is y is equal to mx plus b. I'm going to switch it up a little bit, and in our class, I'm going to call it y is equal to ax plus b. And that's because we're going to rely very heavily on our calculator here. And look, this is just kind of a preview. Y is equal to ax plus b. You can kind of see it right here. Okay. So look, what is going on here? Y is the response variable. Okay. X is the explanatory or predictor variable. And so what are the values of A and B? So B is what we call the y-intercept. In A here, A is our proxy, what we're calling M. This is the slope of the line. And the slope tells us the rate of change of the line. Okay? And so what I'm going to do in this class, okay, is I'm just going to give you a real brief introduction to what exactly what we call regression is. And if you want to take a follow-up math course like a statistics course, let's say, you'll dig much deeper into these concepts. So this is kind of just a quick introduction, and then we're going to jump right to the calculator to how you find this equation of the line. And then if you want a more in-depth study, again, consider taking a statistics course. Okay. So what's going on here? Why do we need to do this? Why do we need to model? Why do we need to fit this with an equation of a line? And so what we do here is we model, we found the equation of the line for the relationship so we can estimate for unknown values. So for example, if you want to study for 5 hours, what grade would you expect? Well, look, I have no data for somebody who studied for 5 hours, okay? I know their exam score would probably be it's going to be between a 65 and 78, but is it closer to 65? Is it closer to 78? Like, what would we expect them to really get? Or if you say, you know what, I want to study for that 10 hours, my data stops at 9, what grade would I expect someone to get if they study for 10 hours? Okay, well, obviously over an 88, but like what exactly? And so that's the point here. That's what we want to do with this. We want to get this equation so we can use the equation somehow to estimate for unknown values. And what we're doing here to do this is we're actually looking for what's called the best fit, the line that best fits the data. So like if you look at this line here, this line does not fit the data. This line does not fit the data well. This one doesn't. This one doesn't. This one does. Okay, so it's like, how do we find this line? Okay, how do we find this line out of all of the lines there? So how do we find the equation for this line? All right. So what we're going to do is we're going to use a process. So we can find this best fit line by using what's called least squares regression. Okay, and we're going to use this line here to make projections here. And so the process for this, the way you find the best fit line, okay, so the best fit line is the line that minimizes the errors. It's actually minimize the sum of the squared errors, but what I mean by errors is all these lines, there's no line that can best fit or go through all the data because the data doesn't follow a straight perfect line. So when a data misses a data point here like this, that distance is an error. Okay, so there's another error here. At that distance, it made a little error. And then there's an error over here, little error. And so all the best fit line does, is, look, it says it's the line that minimizes the error. It makes the smallest amount of mistakes, okay? And we're going to use our calculator to find this line. Okay? And I'm going to show you how to do that by working through two examples, okay? We're going to continue on with the hours of study and exam score example, okay? And then what we're going to do is I'm going to do a whole nother one where we're going to we're going to work through everything we've learned so far again so you can get another good example of all this stuff. Okay, so have your trusty TI calculator ready as we go through this. Okay. So here's our example. Let's find the best fit line for our example. So again, we have this hours of study and exam score. And so the best fit line is this equation that we call y is equal to ax plus b. And just so we're clear here, what y is, all right, from our example, x is our hours of study and the exam score is my y variable. So what this equation is giving us is saying your exam score is equal to some value a times the hours of study that you'll put in plus some value we call the intercept here, okay? So look, in your calculator, going back, so grab your calculator. The way this is done, all right, is the same way you get the correlation value. You're going to, in your calculator, you're going to press the stat button. So you're going to go stat. You're going to scroll over to calc. And you see this option number 4, it's called linreg. That stands for linear regression. Okay, so this is the method to find the best fit line. So it says linreg ax plus b. Okay, so this is what you did. You went stat, you scrolled over to calc, and then it was option number 4 there. Okay, this linreg ax plus b. And what I'm going to do is I'm going to round all values to 2 decimal places. So you'll look in your calculator, this is what you see, okay, when you go to number 4. So you're going to have to scroll down to calculate. All right, now if you have a TI-83, what'll happen is when you go to linreg ax plus b, it'll just say that again. Just hit enter. Here, you're going to see this. All right. So you see this. It says, look, here's your equation. Y is equal to ax plus b. It says a is equal to, so here it's going to be 2 decimal places, 5.03. And b is equal to, it looks like 45.08. All right, so we have to plug this into our equation. So this is what it's saying. Y is equal to a, which is 5.03, times x, which is going to be how many hours you're going to study, plus 45.08. And what I'm claiming to you is that this right here is the line that best fits your data. Okay, so it's really like your calculator just boom, boom, boom. It just does it for you really, really quickly. All right, so let's now plot the line in our calculator, and does the line fit the data well? All right, so I want to show you how to do that in your calculator here. So to plot a line in your calculator, what you're going to do is, so right off the bat, first off, even before I do that, you still have your data plugged into your calculator here. Okay. So you're going to hit y equals, you're going to go 5.03 times the x variable, which is this button right here puts the x variable, plus 45.08. Now when you have this plugged in here, when you hit the y equals, you're going to hit the graph button. And now watch, look what happens. It puts the line right through the data, okay? And you can see, like, look how well this line models the data or goes through it. So it models it really, really, really well, okay? So yes, the equation y is equal to 5.03x plus 45.08 does fit the data well. I'm going to say very well. Awesome. Awesome. That's great. Now watch what we're going to do. We're going to use it to make some projections, okay? So use your best fit line, as I said, to estimate the exam score for someone who studies for 5 hours. So this is what we have. Y is equal to 5.03x plus 45.08. Well, look, I'm telling you somebody is studying for 5 hours. Okay, so you're given the x variable. Remember, x here is the hours of study. Okay? So you're given x is equal to 5. And you want to estimate an exam score. Okay? So what that means is it's asking you to solve for y. So all you're going to do is you're going to take this and you're going to plug x is equal to 5 into your equation. So watch what happens when I do. Y is equal to 5.03 times 5 plus 45.08. Let's see what we get. 5.03 times 5 plus 45.08. You get a 70.23. So I'm just going to round this to a 70. And let's see if that makes sense, right? So looking back, 70, oh, wow, look at that. It does fall between 65 and 78, which is what we said we should get, somewhere between there. We know it's going to be closer to the 65 here in this case. So we estimate that for someone who studies for 5 hours will score a 70 on the exam. Okay, now let's do the same thing. Use your best fit line to estimate the exam score for someone who studies for 10 hours. So again, you're given x is equal to 10 here. Boom, you got it. So all you're going to do is you're going to plug this into the equation. So y is equal to 5.03x plus 45.08. That's our equation. And let's plug in 10. Let's see what we get. .03 times 10 plus 45.08, 95.38. Okay, so we would estimate that you're going to study for 10 hours. You're going to get over a 95 on this exam. That's great. So again, I'll round this to 95. And look, going back, we said, looking here, like even just going back, we said here it's going to be over an 88, and we know here now it's going to be that 95. We would estimate that that person would get a 95 on it. So we estimate that for someone who studies for 10 hours, they will score a 95 on the exam. Awesome. Awesome. All right, so let's now, over the last 3 lectures, right, we've introduced scatter plots, correlation, and then this regression line. So let's now work a second example that kind of starts over and brings this all home, okay, with another full example here. Okay. So here's going to be the problem. All right. The following table shows the max dive time in minutes based on depth and feet of a scuba diver, okay? So this is what's going on here. If a scuba diver is going at a depth of 20 feet, okay, underwater, their max dive time is 100 minutes. And then you can see going forward 30 minutes, or 30 feet, excuse me, underwater, their max dive time falls. It's only 95 minutes. 40 feet underwater, the max dive time falls to 91 minutes. 50 feet underwater, the max dive time falls to 83 minutes. 60 feet underwater, the max dive time falls to 70 minutes. Okay, and so what you're seeing as depth increases, max dive time falls. Okay, so what's going on here is you should have a negative relationship, because as one variable is increasing, the other one is decreasing. All right, so the first question it says, right, we have 2 variables. We have to figure out which is the explanatory variable and which is the response variable. And so what's going on here is I think your depth tells you how long you can dive for. Okay, so my depth is going to be my x variable here. And my response variable then, my max dive time depends on the depth. So my y variable here is that max dive time. Okay. So now I want to examine that relationship first with the scatter plot. So grab your calculator Now here's what you have to do. Okay, you have to clear everything out that you've done. Okay, so if you've been following along, you got to go into y equals. You have to clear this out. And then we have to input this data. All right, so go to stat. And under number 1, again, you want to edit the list and you want to clear the data out. So the way you're going to clear this data, this is important. Please follow this instruction. You're going to go to your mouse, you're going to take this arrow, you're going to go to the top of the list and you're going to hit clear and then enter. Scroll over to L1, you're going to hit clear, then enter. Never hit the delete button. Don't do that. So then X goes under L1. So that's 20, 30, 40, 50, and 60. And then in L2, you get these max dive times, right? So 100, 95, 91, 83, and 70. Okay? So then what you now need to do is, again, you need to make sure your stat plot is on. And if you haven't changed anything, okay? If you haven't changed anything, it's going to be on. So mine says plot 1 on, and I see the scatter plot. What you always have to do, okay, is you always have to go to zoom, and you always have, every time you do a new problem, you have to re-zoom it. So zoom stat. And this, boom, is what I see. Now look at that. Okay, this looks like it's sloping downward. It's pretty good, you know, pretty linear. Okay, so this looks like a negative linear relationship here. That's what we're observing here. We're observing a negative linear relationship. So I'm just going to show you again, you know, in the notes here what that scatter plot roughly looked like. So just. Okay, so again, we got this, we are observing a negative linear relationship. All right, so we're going to calculate the value of R, and we're going to round to 4 decimal places. Okay, and you're going to use the calculator for this. Always going to use your calculator. Okay, you're going to use this TI calculator. So to do this, you're going to press the stat button. You're going to scroll over to calc, and you're going to want option number 4 here. Option number 4. Okay, it's always this linreg AX plus B. So we're going to go to calculate, and boom, you got it right here. Okay, so it's saying R is equal to, look down here. So because it's a negative linear relationship, we would expect R to be negative, and that's what we want, okay? So R is saying R is equal to 0.9701. And look what that means. Because that value is so close to +1, we have strong evidence of a negative linear relationship between the variables. Okay, here between depth and max dive time. Okay. All right, let's now obviously, okay, so we did scatter plot, boom, we got this R. Let's now do the linear regression stuff, okay? So the best fit line. All right, so find this best fit line. All right, so this is that y is equal to ax plus b. All right, and so just so we're clear, what's going on here? Y is your max depth time, and x is your depth. max dive time, okay, max dive time, and then x is depth. So y is equal to, and so again, you're going to use the TI calculator. Always, always, always. Well, look, right here you can see A. A is saying it's negative 0.72, negative 0.72 times x plus, and then let's see what the intercept is. B, 116.6. And this is our best fit line. All right. And look, let me show you that it fits the data well. Okay, let me show you that. So again, just to plug this stuff in, okay, you're going to press the y equals. And to have this negative, you're going to use this. Don't use the subtraction sign. So this is the negative right where my mouse is. Negative 0.72 times x plus 116.6. All right, now let's watch what happens when I hit graph, okay? And look, it fits the data pretty well. Okay, the data was a lot more spread out, okay? So that's why, you know, you're pretty far away from some values, but there's no line that fits this data better. Okay, this is the best fit one right here. Boom, we got it. Okay. So I'm just going to say in our calculator, we observed the line fits the data well. Okay, 2 questions. Estimate the max dive time. Okay, so we want you to estimate y. So we want you to find y at a depth of 55 feet. So when x depth is 55. So to do that, what are you going to do? Oh, you're just going to plug 55 in for x. So y is equal to minus 0.72 times 55 plus 116.6. Grab your calculator. So you're going to go minus 0.72 times 55 plus 116.6, and you go, look at that, 77. We got it. And look, let's see if that makes sense, right? So we're going to go at a depth of 55 feet, okay, which is between 50 and 60, and it's saying you can go for 77 minutes, which is between 83 and 70. So we got it. That makes sense, all right? So we estimate a max dive time of 77 minutes at a depth of 55 feet. Okay. So now this is interesting. So I'm trying to trick you up here. So just pay very close attention. At what max depth? Okay, at what max depth? So I'm asking you to find x now. Could you dive for 60 minutes? Okay, so when you're given y is equal to 60. Okay, so now all you're going to do is you're going to plug 60 in for y. Okay, and solve for x. So you're going to plug 60 in for y here. So you have to be careful. All right, so this is 60 is equal to minus 0.72 times x plus 116.6. So you have to solve this linear equation, right? So you're going to subtract 116.6 from each side. So these are gone. So 60 minus 116.6, you get minus 56.6. So then to get the x by itself, then you're just going to divide by negative 0.72. These cancel. And I'll round this to one. I'll just round this to a whole number. So it's 78.61. Which is 79. So this is what we're saying here, okay? If you're gonna go for diving for 60 minutes, so if you dive for 60 minutes, okay, we estimate the max depth you could do that at to be 79 feet. So we estimate the max depth, okay, for that at 79 feet. All right, so like if you go back, right? So you're gonna go for 60 minutes, okay? Because you're going for 60 minutes. So obviously it's gonna be you can go at a much larger depth here. So if you're gonna go for 60 minutes, what we're saying, you can do that at 79 feet. All right, class. We're going to move on next we're going to continue talking about scatter plots, correlation, and regression. And our next lecture is going to expand on this by talking about something called time series data and then time series regression.